So lesson number 7 looks at solving more complex radicals. So if we look at class example number 1, we've got 2 radicals and then we have a constant term. Both of the radicals are actually what I would consider to be complex radicals because they're not just the square root of the variable, they're an expression that is being square rooted. So if we look at Billy solving this equation, he solved it incorrectly. So we're going to see where Billy made his mistake. So if this is the original equation, and this was his first step, what did he do to go from the first line to the second line? Okay, and did he do that correctly? Yeah. I'm subtracting, so to get rid of this expression I would add, so he's done that line correctly. Okay? In the third line, what did he do? He's squaring it. Is that a correct move? Can I do that? Yeah, as long as I square both sides, so that part is correct. Okay, what about in the next line, the fourth line? So is this squared correctly? If I take the square root of 3a plus 4 and I square it, do I get 3a plus 4? Okay. If I take this expression and I square it, do I end up with this? Well, let's check. If I go 3 plus root a plus 1 times 3 plus root a plus 1. When I multiply 3 by 3, I get 9. When I multiply 3 by root a plus 1, and then when I multiply root a plus 1 times 3, I'll get a 3 root a plus 1. And then when I multiply root a plus 1 times root a plus 1, what will I get? A plus 1. So where did he make his mistake? In this row right here. Okay, and it is the most common mistake that's made because when we see this squared, we square the first term, we square the last term, and we completely forget that I had to distribute the outside and the inside terms with each other. So if we correct this now, I have on the left-hand side my 3a plus 4. The right-hand side, I have this a, and then I have this 9 and 1 is 10. And then I have the two 3 root a's plus 1, which would give me 6 of them. Now, the idea is I want to get this by itself because I'm going to have to square again in order to get rid of that radical. So I move the 10 and the a to the other side, and I would get 2a minus 6. And now I would square. So when I square the left-hand side of the equation, what will I get? So take a moment to complete this line. So what do I get when I take 2a minus 6 and I square it?
4a squared minus 24a plus 36.
So if I didn't want to have to write it out twice and FOIL it out or distribute it out, square the first, square the last, and if I multiply these two together and double it, there's my middle term. And that works for all of them. It works for this one. Square the first, there's the 9. Square the last, there's the a plus 1. multiply these two together and double it. There's my 6 root a plus 1. What do I get on the right-hand side? So square 6 and square root a plus 1. The only thing I need to make sure, put the brackets around. 4a squared minus 24a plus 36 will equal 36a plus 36. To solve this, I need to pull everything over onto one side of the equation, so I'm going to pull everything over to the left side. Subtract by 36 on each side, so it's 24 minus 30, or sorry, negative 24 minus 36. And 36 minus 36? 0. So I get 4a squared minus 60a equals 0. What does each term have in common? What can I factor out of each term? Because it's not a trinomial, so I'm not doing my product and sum charts. If I factor out a 4a, what am I left with? So if I let 4a equal 0, a would then equal, and if I let a minus 15 equal 0, a would equal 15. And then I need to check these two answers. I need to verify them. So if a equals 0, I have the square root of 3 times 0 plus 4 minus the square root of 0 plus 1. It's supposed to be a plus 1. And that's supposed to equal 3, right? But I don't put the equal sign, I put a line. So 3 times 0 is 0, so I get the square root of 4 minus the square root of 1. So what's the square root of 4? And the square root of 1? What's 2 minus 1? Is this a valid solution? No. So this gets crossed out. So now I check if a equals 15. So I get the square root of 3 times 15 plus 4 minus the square root of 15 plus 1. So 3 times 15 is 45 plus 4. Then square root of 49 minus the square root of 16. What is the square root of 49? And the square root of 16? And 7 minus 4. So that one worked. So my solution to this equation becomes a equals 15. Okay, next one. This one's a problem-solving equation, so we have to come up with the equation this time. When the square root of 2 less than a number is subtracted from the square root of 5 more than twice a number, the result is 3. So I'm going to give you a moment. I want you to read through that and see if you can come up with what the equation should look like. So the square root of 2 less than a number. I know I have a square root. How do I write 2 less than a number? X minus 2. Okay? And it is subtracted from. So is it this minus the next part, or is it the next part minus this?
The next part.
Yeah, it has to come here. So think of it as 6 subtracted from 10. So if I take 6 and I subtract it from 10, it's 10 minus 6. So from the square root of 5 more than twice the number, what does that look like?
2x plus 5.
The result is 3.
3.
Equals 3. So now we need to solve this equation to determine what the number is. So we solve this much the similar way that we did the last question. We isolate the more complex radical. Which of these is more complex? 2x plus 5. And this one's easier to move over to the other side because it's going to become positive. So square root of 2x plus 5 will equal 3 plus the square root of x minus 2. Then what would I do? So we'll do it just so that you don't get too far ahead. And so if I square both sides, what do I get when I square the left-hand side? And then when I square the right-hand side, so I square the first, I get 9. I square the last, I'll get, and in the middle, I'm going to multiply these two together and double them. So I get 3 root x minus 2, which when I double would give me 6. So that's what it would look like. So I'm going to move everything on to, well, first of all, 9 minus 2 would be 7. So now if I move this x over, I'm going to get 1x here. Move this 7 over, I'll get x minus 2 equals 6 times root x minus 2. And then I have to square again. So when I square the right-hand side, I'll get 36 times x minus 2. And when I square the left-hand side, I square the first term, I square the last term, and then I multiply these two together and double them. So double negative 2x would be negative 4x. I need to remove the bracket on the right-hand side. And then my last step will be to collect my like terms or move everything onto one side of the equation. So I'll have x squared. If I bring the 36 over, what will happen with the 36 and the negative 4x? Okay. And when I bring the negative 72 over, I will get
76.
So now I need two numbers that when I multiply them together, I get 76. And when I add them, I get negative 40. So 38 and 2, are they both negative, both positive, either or?
Both negative.
So x minus 2 and x minus 38, which means my numbers could be x equals and x equals. So now I need to verify both of those. So start off by verifying if x equals 2. So I verify into the original equation. So I'll have the square root of 2 times 2 plus 5 minus the square root of 2 minus 2 is equal to 3. So 2 times 2 is 4 plus 5? And 2 minus 2? Square root of 9? Square root of 0? Do the two sides match up? Yeah? So x equals 2 is a viable solution. And now I do the same thing with 38. So 2 times 38 plus 5 minus the square root of 38 minus 2. So what is 2 times 38 plus 5? 81. And 38 minus 2? Square root of 81? Square root of 36? And the difference is, so is this a viable solution? So the numbers are 2 and 38. Either one of those numbers will fit the solution or fit the equation. So the questions that I want you to do, 1A, 2A, 4,